We have a two-part problem on the board. We've got this function, f of x equals x squared minus 4x. That's just this parabola that I've drawn a rough sketch of here. And we've got two things we're asked to do. First of all, we want to find a formula for f prime of x. That's the derivative function. That's the function where the input is just x, which is the x value of the point of tangency. And the output of this function is the slope of the tangent line at that point x. Okay, so the function f, the output of that gives me the height of this function. So that when I plug in 5, for example, I get 25 minus 20, I get 5. So the height of the function there is 5. F prime, the output isn't the y value on this graph, it's the slope of the tangent line on this graph. So it's related to f of x, but it's a different function that we're building. All right, that's our first task. The second task looks fairly familiar. We did this in the last section. We're going to find an equation for the tangent line when x is negative 1. But what we're going to see is that in order to get a tangent line, you need two things. You need a point and the slope. Up until now, to find the slope, we've been evaluating a limit. We're going to be able to, since we're going to evaluate a limit in part A, we're going to be able to use the formula that we get in part A to make finding the slope in part B go a lot faster. All right, so let's start with part A. I always like to have a picture. So I'm just going to say, here's my arbitrary point x, and then the y value there is x squared minus 4x. And then I'll choose a nearby point, which I'm going to call x plus h. You'll notice I've drawn my x plus h so that it's to the left of x. That just means I happen to have made a choice that h for my picture is negative. Algebraically, h is a variable that can be positive or negative. Okay. And then I want to evaluate here f of x plus h. Now, that's a function composition. That's taking x plus h, and that's plugging it in for x. And sometimes that feels a little bit weird, because obviously x plus h and x are not the same thing. They're representing different points. In the formula for a function, x is really just a placeholder for my input. And so when I'm plugging something into f, I sometimes find it helpful to just put parentheses around the x's. There are parentheses around x here. Whatever I plug in for x here, I'm going to plug in for x here. So I can say that my formula for f of x plus h is going to be my input squared minus 4 times my input. But what's my input when I'm looking at f of x plus h? Well, the input is what goes in parentheses. So whatever goes in these parentheses goes in these parentheses too. So that's going to be x plus h squared minus 4 copies of the quantity x plus h. Very, very important when you're setting these up that you do this function composition correctly. This is not the same thing as f of x plus h. We add h to x first, and that becomes the input to our function. Okay. All right, so then I can draw in that secant line, and then I can say f prime of x is going to be the limit. Now it's the limit as this point moves closer and closer to this point, but I've set it up so that that happens as h approaches 0, because h is just the signed distance between my x values. So then rise over run, that's going to be x plus h squared minus 4 times x plus h. That's my f of x plus h, minus x squared minus 4x. Do be very careful. This function had two terms here. I'm subtracting that whole thing. So when there's more than one term, it's got to be in parentheses so that this subtraction sign applies to both terms. Then the run is just x plus h minus x, and I know that that simplifies to h. Just a reminder, in order to get just h here and not negative h, I've got to do the subtraction in this order so that I start with the more complicated point and I subtract the simpler point. Okay, top and bottom should both be going to 0 here. And let's just work this out. This will be the limit as h goes to 0. Now x plus h squared, that's just going to be x plus h times x plus h. Here I'm going to distribute that minus 4. So that's going to become minus 4x minus 4h. And here I need to distribute that negative. So that's minus x squared plus 4x all over h. Again, I'm going to need to FOIL that out. So this is going to be the limit as h goes to 0 of x squared plus 2xh plus h squared minus 4x minus 4h minus x squared plus 4x all over h. Okay, now some terms are going to cancel. Here's an x squared and here's a minus x squared. Here's a minus 4x and here's a plus 4x. Those terms are going to cancel each other out. Okay. If I had forgotten to distribute my negative, they would not cancel out. And it's super important that they do, because notice what's happened here is that every term that's left now has at least one h in it on top. Okay. All the terms that didn't have any h's in them canceled out, so there's an h in every single term on top. If that didn't happen, that would be a sign that I probably made a mistake in my algebra somewhere. Either I evaluated my function composition when I plugged in x plus h incorrectly, or maybe I forgot to distribute a negative, and there were a couple negatives that we had to distribute in this case. Okay. With that happening, I can now factor out an h on the top. So this is the limit as h goes to 0. On top, I can factor out that h, and then I've got 2x plus h minus 4 over h. Now I can do what I've been wanting to do. I can cancel that. And so this is the limit as h goes to 0 of 2x plus h minus 4. I can now plug in 0 for that h, and so I get 2x minus 4. So what we've got is that our formula for the derivative function is 2x minus 4. Excellent. Okay, the second part of the question, we wanted to find an equation for the tangent line when x was equal to negative 1. Okay, so to find a line, I need two things. I need a point and I need the slope. Now the point, we were given the x value, but we weren't given the y value. So I'm going to need to plug in to find that, and I'm going to plug into f. So f of negative 1 would be negative 1 squared, which is 1, minus 4 times negative 1. So that's negative 1 plus 4, that's going to be 5. Okay. The slope is f prime at negative 1. Now, the last time we did this, we had to set up and evaluate a limit. I don't have to do that now because I've got this formula for f prime. So all I have to do is plug in negative 1 for x. That's going to give me negative 2 minus 4. That's going to give me negative 6. Now, if I look over here, I didn't draw this perfectly to scale, but I did draw this so that it had x-intercepts at 0 and 4. So negative 1 would be over here. So what we've just said is that we've got this point negative 1, 5, and that the slope of the tangent line at that point was negative 6. That looks about right. It does look like I should be going down, so we should have a negative slope, and it's fairly steep. Kind of nice to be able to confirm graphically what we got using the algebra. Okay. But now I can go ahead and find an equation for this line. I'm going to just redraw my picture. So we had this point, negative 1, 5. We're finding the equation for this tangent line. And remember, what we're doing then is we're just describing an arbitrary point on that line. And I like to think of it as it's just rise is equal to slope times run, where I'm going to calculate the rise and the run using my specific point, which was the point of tangency, and my arbitrary point. So the rise would just be y minus 5. The slope we calculated is negative 6. And the run is x minus a negative 1. I'm fine with you leaving things in point slope form. I would ask you to simplify so that rather than writing that I'm subtracting a negative, I would simplify that to be just x plus 1. If you wanted to work this out further and solve all the way for y, that's totally fine, but not necessary. Okay.